Let G be a set. In this set, AB and AB are real numbers and A is not equal to 0, means order pair in which first element is non-zero. Be a group with respect to a binary operation star on G. Define as, if we are taking two elements, means two order pair, then order pair combine by this method. For all two order pair, then the inverse of element 2, 3, which is belonging to group G. We are finding inverse of an element particular 2, 3. Inverse of 2, 3 we have to find out. So question mark. We can only find inverse whenever we know or have the idea about the identity element. Now, what is identity element? Identity element of this group G, and we know that identity element is unique. So first we are going to find identity element. By the definition of identity element, if we take an element from the group, if we operate identity with an element, then it returns same element. Using this definition, we are going to take an element of G, means an order pair AB, and suppose identity element is C, D, that will return element itself. How these two elements combine? By the definition of binary operation, you can see AC, BC plus D is equal to EB. And these two order pair are equal. It means AC equal to A and BC plus D is equal B. Now solve these two. Take common. A C minus 1 is equal to 0, and I already taken A is non-zero as defining element in G. You can see here A is non-zero. If we are taking an element in order pair, then first element is non-zero and there is no condition on second element, means second component of the order pair. We know that A is not equal to 0, so C equal to 1. Call it equation 1. Now from this one, take B. C minus 1 plus D is equal 0. Means transpose these two. Means taken in same side, and after that B is a common. So C minus 1 plus D. This is only calculation. And we have the value of C. Means B 1 minus 1 plus D is 0. This is going to be 0. So D equal to 0. Means we know the element CD. Now value of element CD is 1, 0. This is identity element E. Call it identity element. Now find inverse. Inverse of the element 2, 3. The inverse of this element, suppose CD is the inverse of this. By the definition of inverse, this operate with these two will return identity. And how they combine? 2C, 3C plus D equal to identity element is 1, 0. So 1, 0. These two order pair are equal. This implies that 2C equal to 1 means C equal to half, and 3C plus D equal to 0. Value of C is half, so 3 by 2 plus D is equal to 0. This implies D equal to minus 3 by 2. Means CD is nothing but half, minus 3 by 2. Now check which one option is giving half minus 3 by 2. Option C is the same. So option C is correct answer. order and degree of the differential equation within bracket 1 plus dy upon dx square whole cube is equal to d2y upon dx2 raised to the power 3 by 2. We know that order of the differential equation never be a fractional number. So option D discard here because of rational is given. 3 by 2 is a rational. So option D discard here. Keep remember order and degree can be easily find out when the given differential equation is free from radical. This differential equation 1 plus dy upon d square whole cube is equal to d2y upon dx2 raised to the power 3 by 2. To remove this radical part or fractional power, we square both sides of this differential equation. So now differential equation is d2y upon dx2 raised to the power 3, and this one will be 1 plus dy upon dx square whole 6. Now differential equation is free from radical. Now order is maximum time we differentiate. So 2 time and its power is 3. So degree is 3. So order 2 and degree 3 option A is true here. Let V equal to M2 by 2 matrices for which entries are real, be a vector space and M is this particular matrix. Let T is a linear transformation from vector space, same vector space V to V, be a linear map such that for input A, T send image of A by AM minus MA, then the rank of T is. We have to find the rank of T. And given that matrix M is 1, 0, 2, 3, this is matrix given. And for image of A, T send image of A as AM minus MA. Vector space V is given M2 by 2 over R, means matrices all 2 by 2 matrices entries are real. So dimension of V is 4. Because of 4 independent choice we can consider as A, B, C, D. Now consider this is a matrix A. Now we are going to find image of T, image of A. So consider this is matrix A, B, C, D, 1, 0, 2, 3. This is matrix M. M is 1, 0, 2, 3. This is matrix A, B, C, D. Now solve this. We will get A 2A plus 3B, C 3C plus 2C plus 3D minus multiply these two bracket A plus 2C, B plus 2D, 3C and 3D. Now subtract these two, we will get minus 2C, minus 2C, 2C, and this one will be 2A plus 2B minus 2D. If we have the value of C and this element, suppose this element is X. For matrix A, because we choose in freely A, B, C, D, so value of A, B, D will give you this element. It means we have two independent choices as C and this X. So rank is 2 because of rank is dimension of image of T. Rank is dimension of T, or you can consider as we obtain this matrix we have two non-zero rows. two non-zero rows, this one and this one. So rank of this one is also 2. By nullity, nullity of T will be 2. How nullity will be 2? Because of rank nullity theorem. Because of dimension of this V is 4, rank plus nullity will be 4. Rank is 2, then nullity will be, nullity implies 4 minus 2 means 2. So you can find rank and nullity for this linear transformation. So option C is true. If W is the subspace of mn by n matrices over real number, consider the diagonal matrices, then dimension of W is, we have to tell about dimension of W. W is subspace of n by n matrices, means these are the entries of the matrices, and size of the matrices n by n, and entries are real number, means if you pick an element A, then A should be from real number. It may be 0, 1, minus 1, fractional, rational, anyone from the real line. So these are the elements of W. Now we have to tell about dimension of W. In short, you can understand dimension is number of independent choices we have. Means to generate an element W, to generate an element of W, then how many independent choices we have. I am not saying for a particular element of W, any element. For all element, how many independent choices we have to generate an element of W. W contains only diagonal element, means diagonal, not a scalar. Remember one point, scalar matrices also will come in diagonal matrices. So suppose A, B, C, D, E, F, G, these are non-zero entries. It may be 0 or non-zero. Means we have independent choices only these. Other entries are 0. So I put it big 0. So how many? Because of size of the matrices is n by n. So n independent choices we have. So dimension of W is n. If you have studied linear algebra in earlier classes, then you can directly put the answer. So option A is true. The orthogonal trajectories of the curves xy equal to c square are. How to find orthogonal trajectory? Orthogonal trajectory. This is a function of xy minus c square. This is given. So first eliminate this constant, and to eliminate this constant we need to differentiate this function, means we obtain a differential equation. And orthogonal trajectory means when two curves met at a point and their tangents, suppose these two are tangents, then these two tangents are orthogonal, means intersect at 90 degree, then we say orthogonal curve. They are orthogonal curve, and their tangents are orthogonal. It means m1 m2 minus 1, m is slope. So slope product of two tangent should be negative. This is the condition we studied in 11th or 12th standard or in school level. So obtain orthogonal trajectory, replace dx over dy with minus of dy dx. This is the condition or another form of this one. As function is given to us xy equal to c square, to eliminate this constant c, differentiate this one x dy upon dx plus y equal to 0. Now replace this dy upon dx, x minus dx over dy plus y is 0. This means that dx over dy is equal to minus y upon x, negative cancel out by negative. This one equal to dx over dy y upon x, variable separable method used here, y dy. Now integrate this one, x square equal to y square plus c, means x square minus y square equal to c. This is the orthogonal trajectory, so option D is correct. The value of 2 raised to the power 20 mod 7 is, sometimes this types of question asked, what is the remainder when 2 raised to the power 20 divided by 7? What is the remainder? Remainder when 2 raised to the power 20 is divided by 7, or the value as written, the value of 2 raised to the power 20 mod 7. Asking of question is two type. How to solve this problem? Fermat theorem will help us to find this solution. What is Fermat theorem? 2 raised a raised to the power p is congruent to a mod p with condition GCD of a and p should be 1. Now as power is 20, so break power 20 as prime. So 2 raised to the power 7, because of mod 7 is given, 2 raised to the power 7 raised to the power 3 will be, or you can skip this one, 2 raised to the power 7 congruent to 2 mod 7, because we need 21, so make 3 here, so 3 here, but 7 3 is 21. It is giving us 21, but we need 20, so take inverse, 2 inverse both side, 2 inverse under mod 7, under mod 7. 2 inverse is what number will multiply with 2 and give us 1, means 2 into 4, 2 4 is 8, 8 mod 7 is 1. So 2 inverse is 1, sorry, 2 inverse is 4, 2 inverse is 4, so 4 into, and 2 cube is 1 mod 7, that is 4. The value of this one is 4. Again, you can understand this problem as 2 raised to the power 7 raised to the power 3 was 2 cube mod 7. 2 cube mod 7 means 1 mod 7, and take 2 inverse both side. So 2 inverse here, and 2 inverse is 4. So 4